How do you containerize a container ship? Well, you need the ship sitting there, and you need a crane, and you need someone running the crane. But did you know that if you go inside the crane, there is literally someone sitting there typing commands on a bash terminal? Okay, maybe not literally, but that would be cool. And if they ever automated the job of the human operator, the application they deploy would likely be containerized using something like Docker. Which brings us to the topic of today's video, Docker 101. So despite the snazzy intro, I will admit that covering all of Docker or even a nice introduction to Docker in one short video is probably pretty ambitious, but I'll do my best and just go through it right now. I kind of broke it up into what, why, and how, like we do for some of the other videos here. So we'll start with what is Docker, what will it allow us to do by the end of this video, why do we need it, and how do we use it, obviously. How do we actually get things done with it? So the first one, the what is Docker, and what will we be able to do by the end of this video? Docker is a containerization runtime, so it provides lightweight VMs, and they have a shared kernel. So the shared kernel is key, whereas if you have a regular, chunky, old, massive VM, right, they all have their own resources, their own emulated memory, emulated processors, everything a normal computer would have, they have their own copy of. So they're exactly copying real-life computers. Containers are extremely lightweight because they share the kernel, a single kernel of the host OS usually, and this provides all of the resources that they need. So they don't have to worry about spinning up tons of stuff. You can just use what's already there, and you can spawn tons of them as a result. So people will containerize applications, which means that they'll install all of the software that they need into a container. So it's kind of like having a virtual machine completely dedicated to, for example, a web server or a database. Of course, that would be overkill for VMs or for physical machines, but for containerization, you can afford to do that. So people might do that for a web server or a database. The goal of this video is to explore some publicly available Docker images and containerize a simple Flask web app, which is about as simple as you can get for an application that needs to be containerized. So the why do we need Docker? Well, the old way of doing things is probably the best way to understand why. Consider before containerization where you're assigned a number of servers that you have to do whatever you want with, or virtual machines, whatever they are. It's up to you to decide which applications in your system live on each server. So if you have a single server and you decide to put all of your applications onto that one server, you're going to have a kludge of different libraries related to different components of your system all installed into one environment. If you decide to scale up and you want to go beyond that single VM or server, you're going to have to somehow extricate those packages and split things out, which will be very painful. You have to untangle everything, remove the database libraries that only belong to the database when you move it off of that node. It's just a lot of work. Easy to make mistakes and miss things and inefficiencies, so that's the old way. Docker to the rescue. Each container is supposed to be atomic. That means that the database container has the libraries needed to run the database application and nothing else. So since everything is so well contained and modular, moving nodes around and scaling, adding additional nodes, additional copies of the same node, it's extremely simple. It's just a matter of configuring things in text files usually. So let's get into the how. How do we use Docker? There are two skills that we're going to look at. Terminal commands for Docker, which is when you're interacting with Docker on the command line, checking what you have on your system, running things. And the second one is huge, building custom images. This is what people mean when they say containerizing an application. It's taking everything that you would need to run an app and putting it into an image that can be spawned as a container anywhere else. So the way I see it, the big three for Docker command line use are Docker run, Docker exec, and Docker build. Run is start a new container and run it. Exec is run something on an existing container. And build is build an image. And once the image is built, you can spawn containers from it using the top two commands. And there are a bunch of other diagnostic tools here and other commands, and we can run through these, I suppose, but I think it's best if we just go straight to the command line and try some commands. So I just cleared everything out of Docker doing a docker system prune-a, and that basically reset everything to how it was when I first started. So we're hopefully on the same ground if you're just installing. Next, let's look around and see what's on our system using some of those diagnostic commands. We can do docker image ls to
to see which images we have installed. Now it only shows ones that are being used, so if you do -A, that shows you everything on your system. We can do the same thing with containers. Container ls-a, there's nothing there. So our first command is going to be docker run -it ubuntu bash. So it said it couldn't find it locally, so it's pulling it. You can also do a docker pull command to go get it. Either way, it pulled really quickly, and now we have a root terminal. It looks like a VM. We can do ls clear, print working directory, cd home, there's nothing there, cd/root, there's nothing there either. Basically a whole working system as it appears to your terminal anyway. We can echo stuff in it. Basically a little sandbox for you based on an Ubuntu image available publicly. If we do docker container ls-a, we can see that we just created this container with an ID that's just a random hash from the Ubuntu image. We ran the bash command 43 seconds ago and it exited 11 seconds ago. And the name of the container is automatically generated because we didn't specify it. So it just takes an adjective and someone smart, I think, if I recall, just a random list of scientists and things like that. So what if we drop the IT and just do run ubuntu, which is the image, bash, which is the command? We get nothing. And if we do container ls-a, we can see that we have a second container here on top, exact same random name, and it exited 0 without asking us anything. That's because that -it allocates a pseudo terminal for you to use. Otherwise it just goes away. Same thing if we do docker run -d ubuntu bash. That one's going to run in the background, but it has nothing to do, so it exits. If we want to do a volume share, that's a big one. We can do -v print working directory /app. This is going to share our current directory with the container so that they're basically mirrored. They're the same file system. So you can pass information back and forth using the file system. And we'll do the same thing, Ubuntu bash. I misspelled it. Bash. And it did nothing, so we need IT. Now that we have our terminal, we can go to /app, which is where we mounted our volume. We can touch hello world.txt, and if I grab a new terminal, we can see it was created on the host. Same thing, if we make a file on the host and we ls, it's there. We also see it in the container, so it's sharing the volume back and forth. The last one is going to be a little bit hard to visualize here, but it's -p. So if we do 80:80, that means that port 80 on the host is shared with port 80 in the VM. So you can access things over the network in the VM. You can modify one or the other to share a port in the container and map it to a different port on the host if you'd like to do it that way. So in one container, let's start an Ubuntu container, and we're going to sleep for 100 seconds and hopefully not exit. So if we run that, it's just sitting there sleeping. We can do docker container ls-a, see which container it is. You can use the container ID here, or you can use the name, Thirsty Goldwasser. So we're going to copy that name, and we're going to do docker exec-it, paste the name bash, and here we are inside the container, no problem. We can do whatever we want while this is running, and eventually it's going to run out. I'll kill it right now to make it run out. Okay, I had to wait that one out, unfortunately, but you can see on the left the terminal finished because we ended a 100-second sleep, and the exec terminal that we launched on the right also exited out because the container stopped.
Okay, now that we've tried some commands, let's look at building custom images. Docker images are composed of many layers. Base images, if you ever want to make a base image, like how do they get the Ubuntu image, right? It's actually a tar file, I believe, at the very base. And then from that point, once you have the tar file done, you can use from to just start from another image. So you should never really have to do the tar method. That's just like under the hood type stuff. Really, you're always basing your current image off of a different one. And each time you do a command or anything to that image, it becomes another layer. This allows the image to get rebuilt very quickly, depending on what you change. So really you just have to choose an image that's as close as possible to your application and get going. So here's some basic image instructions. We have from, run, entry point, env, arg, and copy. You can read these if you want, but I think again it's best to see them in practice, so I'll just save it for when we are actually using them. So let's jump into it. If we make a Docker file in this directory and we say from Ubuntu and do nothing, we'll get to how we can do more than this in a bit. We can do docker build. First of all, ls, you can see the Docker file there, docker build -t. I'm just going to call it temp. Dot. Dot means this directory. And it immediately built it because it's just based on another image. So there's not much to do. If you do docker image ls-a, you can see we have Ubuntu, which we downloaded from the internet when we ran our containers to test with. And you can see this temp image that was created just now. And it has the same image ID because there's no difference. So let's see if we can quickly cover all of these. So from, we already know that that's just take an existing image and start there and add on some more layers on top of it, more commands. Run lets us run it as if it's in a shell. So we can run echo hello world, I am building, no problem. You can run anything like copy. Well, you can touch files. So you can say run make directory /app, run touch /app myfile.txt, no problem. We'll also make a directory /app/folder. We can also copy files, which you're probably going to want to do to copy your source files into the container. So you can do copy dot, referring to wherever you're building from, and then you can provide a path in the container, which is going to be /app/folder in this case. We'll see the effects of that in a second. And what else? env, you can set environment variables. So we'll say hello equals world. Arg, you can specify build arguments and you can give default values if you would like. So we'll say myarg equals myarg value. Finally, entry point is the main command that we're running when the container starts. Just a quick note before we go any further. I didn't really understand the difference between CMD and entry point when I made this video, so let's just talk about it real quick. I think what we actually need here is CMD. If you go to the documentation and check out the entry point, it has a lot of words here, right? But basically, I think you can think of shell-c being the default entry point, where you're saying what is actually executing our commands. Most of the time you're assuming it's a bash terminal or something like that. So if you want to change that and eventually pass other commands, if you ever want to change the CMD at some point down the line, that becomes a problem because you can't really override the entry point dynamically as well as you can the CMD. So it's probably best to leave your entry point alone as the default, where it's just running as a shell, and then use command to specify your main executable for your program. I say this only because it's just, in my experience, a lot easier to override command than it is to do so for entry point. Do I know the exact difference? Am I getting this perfectly right? Probably not, but you can read the documentation yourself and make your own decision. I'm just going to say, hey, if you can figure out how to use command instead of entry point first, I would go that route because it's easier to override and it's the less heavy-handed way. That said, I didn't really know this when I made this video. I don't really have any scripts to run, so I'm going to say echo hello world and sleep 100. So let's try to build this. We just say docker build -t temp dot. So what are we seeing here? Each command runs each layer, each step from Ubuntu, no problem. Run echo hello world I'm building, you see it, and it's removing intermediate container. So each time it runs one of these, it's creating a container, and then run make dir, run all of our commands, copy everything. Looks like everything ran, so let's step into the container and see what it looks like. So I'm going to run -it temp, the name of our image. Actually, I'm not going to specify anything, and it should run our echo hello world and sleep. Okay, that was a little more literal than I thought it would be, so whatever, it's fine. So what's going on here is the command is ending, and anything else we try to do doesn't work because the container exits as soon as our entry point finishes. Usually you have something here that is going to last forever, right? You're running a server, it's sitting there listening, it's blocking forever. In our case, it's exiting immediately, which is not what we want. So I'm going to put a 100-second sleep. Hopefully that's enough time to do something before it exits out. So I'm going to rebuild. It ran, and now we'll do docker run -it temp. It's just sleeping. That's great. If I kill it, I can't kill it. Okay, let's go to a different tab here. We're going to do docker container ls-a,
and we have nifty Kepler. So if we do docker exec it nifty Kepler bash, we're in our container. And do we have a /app? We do. If we cd /app, we have our file that we touched, and we have folder here. What's in folder? We have our Docker file, all of our source files, and what else? Environment variables. Let's just see what we've got. We can grep for hello, and we see hello equals world, so that worked. We can grep for myarg, which I don't think is set. Yeah, so arguments don't get set to environment variables unless you specify that they should be. So you can set myarg, the environment variable, equal to myarg, the argument. So that little example image we built is all fine and good, but as promised, why don't we get around to building the Flask app that is containerized that we saw before. So if you clone the education repo on our PageKey Solutions GitHub, I made a Docker folder, and then for this video we have Docker 101. And inside of that we have 3 files. We have the flaskapp.py. This represents your application, in this case a web application. We have requirements.txt, which is standard for Python applications. All we rely on here is Flask, right? So you get a Python environment that has Flask installed on any machine, and you can run flaskapp.py, and you get this little 10-line file. All it does when you access / on the web server that it hosts on port 8080, you get plain text hello world. So if we want to look at that, this is the non-containerized version just running in my local environment, and we can see hello world coming out of it. Now, this is containerized using Docker, using a lot of the things that we just saw. So on my local environment, I'm pretty sure I'm using Python 3.10. No, 3.8.10. Okay. For some reason I used Python 3.10 for this image. Either way, you can specify your Python version, and there's pretty much a Docker image for every Python version, along with other major programming languages. So luckily that's all set up for us. We have working Python from this public image that we have. All we have to do is copy everything in this directory into /app. So in this case, it's just copying these 3 files and making a folder called /app and putting it there, right? Then we're going to pip install our requirements, because remember, the public image is just a blank Python image. It doesn't have any of the packages that we need installed, because most people, I mean, you could need anything, not necessarily Flask. It's pretty specific to a small web app, which is what we're doing. So they don't want to clutter the public Python image with things that don't need to be there. So it's up to us to install our own requirements, which we do with pip install -requirements, and then entry point, or really it should be cmd, which I'll change it now and see if it works. All we're doing is running Python Flask app install our requirements, and we run Python, and yeah, let's see if we can get this working in Docker. So we'll do docker build -t docker 101 dot, and it's pulling the image Python 3.10. It's installing our requirements, and it's done. Okay, so we built the image, and we can see the image has been built, which is great. So if we run that image, or rather if we create a new container from that image, docker run docker 101, let's see what happens. There we go. It is running exactly how we had it before outside of the container. And if we try to visit that, though, it can't connect. So we have an issue where we're not exposing the port that we want to our host. So let's see if we can figure that out and fix it. Okay, after a few attempts, I did get this right. We had to change the host to 0.0.0.0. So in most web applications and things that bind to ports, if you use 0000 as the host, it's going to bind to all publicly available interfaces, rather than if it's just localhost, that's pretty limited to just your computer, or in this case, just the container, which our browser is not privy to that. That's a different localhost than our host computer is expecting, so you can't get inside of it. However, if you change it to 0000 and you rebuild it, which we do with the same command as before, then you can docker run and publish that port, and then you'll see that it's hosting both localhost to the container, and this public 172 address, which is a Docker internal IP address. And then when we open that second one, we do see our hello world coming from our Docker container, which is pretty cool. As always, thanks for watching. I hope you got something out of this Docker tutorial. Leave a comment, a like, maybe even subscribe if you're feeling it. See you for the next one.